Alright, you guys, welcome to your internet classroom. I am Ms. Springfield and I will be taking you on a tour of composite figures. Some of you have already started these notes. If you already have, that's awesome. Just listen to it again, make sure that you're fully understanding everything, and away we go. A composite figure is actually a figure that is composed of different smaller figures. Alright, so we're going to write that down. My pen is not going to work right now. Everybody laugh. Alright. Composite figure is a figure that is composed of smaller figures. A figure that is composed of smaller figures. Alright, and there are 3 steps to finding the area of composite figures. The first step is to identify the smaller figures. And decide if they need to be added or subtracted. And in this video, you'll find that some composite figures you need to add and subtract in order to find the total area of the shaded space. Alright, step number 2 is to use your mathematics chart. Okay, now your math chart is a very special tool that they give you in order to help you solve daily problems like this. So you're going to use your math chart to find the area formulas. Okay, and then once you do that, you're going to find the area of the smaller figures and you're going to add them or subtract them. So step 3, find the areas of the smaller figures and add or subtract. Okay, so you're going to find the area of the smaller figures and you're going to add or subtract. You guys hold on just 1 minute. The sun's coming in my window and it's kind of like a vampire in here. I need to shut it down. Alright, I just didn't need any extra glare. We already have one coming off the whiteboard. Alright, so now if you need to pause the video, now's a great time to do that. Go ahead and pause the video. Make sure that you have these notes written down excellently and that you have them verbatim, which means word for word, that you have them written down in your notes so that you can look back at that. Alright, once you finish that, you may resume the video. Okay? Now you guys, what I'm going to give you is that website that we worked on in class today, so that if you need some extra practice with this, you absolutely feel free to go on there. We're going to be working on some of that again tomorrow, but there's no need in, there's no worry in having a little extra help at home. There's no big deal. Alright, so the website that you're going to is www.learnalberta, LEARNALBERTA.ca/content/MEJHM index.html. So www.learnalberta.ca/content/mejhm/index.html. Alright? And once you're there, you're going to click on the tab that says Shape and Space. You're going to click on Shape and Space. And then you're going to click on Area and Perimeter. Once you've done that, you're going to find a section that says Exploring Composite Figures, and that is what I want you to interact with. It's called Math Interactives. I want you to interact with Exploring Composite Figures. And again, if I read any of that too fast, you can pause the video and this should be shown on your screen. Alright, so now we're going to go over some composite figures that you might see on that Math Interactives website. The first of which is this composite figure. Now when you look at this composite figure, initially I look at it and I see a big rectangle and two triangles. But when I look at it again, I can see two squares and two triangles. So that is what I'm going to use to find my composite shapes because I don't know the height of my rectangle. Okay, so I have two squares and two triangles. Okay, so step one tells me to find my composite figures and decide if I'm going to add them or to subtract them to find the shaded area. Well, in this situation, the shaded area, I need to add the two squares and subtract the two white triangles, kind of like you would with a donut. Okay, you have your initial dough ball and then you cut out the donut hole, which is my favorite part, the donut hole. Alright, so now it says use my math chart to find my area formulas for each of the smaller figures. So I'm going to use this composition notebook, and at the front of the composition notebook we have our mathematics chart. Okay, so I'm going to look in the mathematics chart and I'm going to find the section that's labeled area, and I'm going to find the area of a square. Area of a square, it says the formula is area equals side squared. So I'm going to write side squared here for this square. And I'm going to write the same thing for the second square. And I'm going to subtract the area of the white triangle. So the area of a triangle is 1/2 base times height. Okay, and I do the same thing for the second triangle. Okay, so now I'm going to switch to another screen just so I'm sure that we have enough room to go ahead and work this all out. So I'm going to switch and it's going to be the same problem. So we originated with side squared plus side squared minus 1/2 base times height of the triangle minus 1/2 base times height of the triangle. So the side squared of the square and 1/2 base times height of the triangle. Alright, so now I look at my figure and I say, okay, the side of my square. I didn't need to draw in that square again. Okay, one side of my square, if the total is 8 centimeters, then one side, one of the squares is going to be 4 centimeters. So one side is 4 centimeters and the other side is 4 centimeters. 4 squared. Okay, I do the same thing here, 4 squared plus 4 squared. Now I need to subtract out the areas of the triangle. So I need to find the base of the triangle and the height of a triangle. Now when we're talking about the area of a triangle, the base always has to be perpendicular to the height. Okay, so when I look at this, the only two sides of the triangle that are perpendicular are the one it's sitting on and the one that goes up. So the base of this triangle is 2, and the height of this triangle you'll find over here is 2 centimeters as well. So 1/2, the base is 2 centimeters and the height is 2 centimeters. Okay, and I'm going to to do the same thing for the second triangle because they're identical. 1/2 of 2 times 2. All right. Now I need to work out these individual areas and then add them or subtract them. 4 squared is 16. Plus 4 squared again is 16. Minus 1/2 of 2. Half of 2 is 1. 1 times 2 is 2. Minus 1/2 of 2 is 1. 1 times 2 is 2. So now I subtract it piece by piece. 16 plus 16 is 32 minus 2 minus 2. 32 minus 2 is 30 minus 2, and 30 minus 2 is 28. Now I need to look at my units, centimeters, and I know the area is always squared, so it is square centimeters. Okay, so if you had no problem following along with this, that is awesome. If not, if you did have a little bit of trouble following, rewind it. It's okay. Rewind it and just start again and follow along until you get it. The next problem I'm going to have you do, I'm going to have you do it by yourself. Okay, so when you look at this problem, I need you to first identify the smaller shapes that make up the bigger shape. Okay, and then you need to figure out, are you going to add or subtract those shapes? Use your math chart to find those formulas, and then find the areas of each of those smaller shapes and add them or subtract them. All right, so pause the video now, and when you're finished, when you're finished doing the problem on your own, you may resume the video. Okay, you guys, when I look at this figure, I see a rectangle, 2 half circles, and a square. So I have a rectangle, 2 half circles, and a square. Now I need to decide, am I going to add these or am I going to subtract these? Well, to find the area of the shaded region, I need to add the rectangles and the squares. But again, this has like a donut shape in the middle, so I need to subtract out, the rectangle and the half circles I need to add. But this donut, this donut like square in the middle needs to be subtracted. So I need to add the rectangle plus the half circle plus the other half circle, and then subtract out the square. So now I need to go to my mathematics chart and find the area of a rectangle. The area of a rectangle is found by you looking at the base times the height. Now I need to find the area of a half circle. Oh, that one's not on there, but in its name it tells me how I can find its formula. Half of a circle means I can find half of the area of a circle. So looking at the formula for the area of a circle, it says pi r squared. So in order to find half of that, I just simply divide that by 2, or I can write 1/2 pi r squared. And then I have another one, plus 1/2 pi r squared, minus the area of this square, which the formula is area equals side squared, which I found on the other one. I almost dropped my marker. So base times height plus 1/2 pi r squared plus 1/2 pi r squared minus side squared. Okay? Now again, I'm going to switch to the next slide. I'm going to draw in my little, what I can see. And I'm going to write out the formula again. Base times height plus 1/2 pi r squared plus 1/2 pi times r squared minus side squared. Okay, so now I need to find the base of that rectangle. The base of that rectangle is 6. Multiply that by the height of that rectangle, which happens to also be the diameter of my half circle, which is 4, plus 1/2 times pi. Look on my math chart, pi is at the bottom. It's approximately 3. R stands for radius. Now, I'm not given radius on this figure, but I know that radius is always half of my diameter. So if my diameter is 4, what is my radius? Yep, it's 2, you're right. Okay, so the radius of that circle is 2, so 3 times 2 squared plus 1/2 pi is approximately 3 again. And the radius of this circle is the same, so it's going to be 2 squared minus the side of my square, which is 2 as well. Okay, now I need to multiply out these individual areas and then add or subtract. So 6 times 4 is 24. 1/2 of 3 times 2 squared, so I need to leave that as it is. 1/2 times 3 times, what's 2 squared? 2 squared means 2 times 2, which is 4. Plus 1/2 times 3 times 2 squared, which is 4, minus 2 squared, which is 4. Okay, so now I need to multiply these two out again, the area of these triangles. So we are, just kidding, not triangles, they're the area of half circles. So 24 plus 1/2 of 3 times 4. 3 times 4 is 12. 12 divided by 2 is 6. Same thing here, 1/2 of 3 times 4. 3 times 4 is 12. 12 divided by 2 is 6 minus 4. 24 plus 6 is 30 plus 6 minus 4. 30 plus 6 is 36 minus 4. And 36 minus 4 is 32. Now I look at my units again. We had centimeters. Area is always squared, so it's going to be centimeters squared. Or square centimeters, however you would like to say it. Okay? If you're still doing great, that's awesome. We're going to move on. If not, rewind this video, maybe spend some time at the Math Interactives website, and then come back to the third example. Alright, so we have one more problem that I want you to do, so we're going to go to that problem. Pause the tape now, do this on your own, and once you have completed it, resume the video, and we will continue working. Alright, now you guys, we're going to do the first step, which is identify which figures make up the bigger figure. So when I look at this, I see one big rectangle, and I see 2 donut holes. Alright, so my shapes are a rectangle and 2 circles. Now if I'm just trying to find the area of the shaded region, I need to subtract out those 2 circles. So I have the rectangle, and I'm going to subtract the 2 circles. Alright, my next step is to look at my mathematics chart and find the area of a rectangle and the area of a circle. When I look for the section that says area of a rectangle, I find that the area is base times height. And I subtract the area of one circle, which is pi r squared. And I do the same thing, same formula for any circle, pi r squared. Alright, so now I need to find the base of my rectangle. The base of my rectangle is 8, and the height of my rectangle is 4. Subtract pi, which is approximately 3, and the radius of my circle, oh, they gave me the diameter again, but I know that the diameter is 2 radiuses, or the radius is half of the diameter, which would be, if the full diameter is 2, then the radius is 1. So 3 times 1 squared minus pi is approximately 3 times 1 squared. Okay, so now I need to work these out. I'm going to go to the next slide. So I have 8 times 4 minus 3 times 1 squared minus 3 times 1 squared. Okay, so I have 8 times 4 minus 3 times 1 squared minus 3 times 1 squared. Alright, so I need to multiply 8 times 4, which is 32, and subtract 3 times 1 squared. So I need to multiply out 1 squared first. 1 squared means 1 times itself, so 1 times 1, which is 1. Do the same thing on the next one, 1 times 1, which is 1. 32 minus 3 times 1 is 3. 3 times 1 is 3. 32 minus 3 is 29 minus 3. 29 minus 3 is 26. Again, my unit is centimeters, and it's centimeters squared or squared centimeters. Alright, so you guys, we're going to do some more of this in class tomorrow. If you're still a little iffy, write down some questions for me, and we'll talk about them in class. If you have any cellular devices and you want to bring them to school tomorrow, it's a perfect day. Parents, I give them full permission to bring their cellular devices if it's okay with you. We've been using them in class to do some technological activities, so if you want to let them bring them, that's fine. If you don't, it's okay. We'll find other ways we can do them as group assignments. Alright, so if you're doing great on these, that's awesome. If you need a little extra assistance, go ahead and rewind it and watch it again. It's not a big deal, really. Get it or do it until you understand. Also, that website is a wonderful website to go ahead and play on. So I will see you guys tomorrow morning. Have a wonderful evening.